Hello students! In this video we're going to look at the 3 types of transformations tested by the SOL. This is part of SOL G3, Coordinate Geometry. The 3 types of transformations are translations, reflections, and rotations. Here I've got 3 pictures for us to look at that do a good job of describing each type of transformation. The first is a translation. The original triangle is the purple one on the left. It has been copied here to the right 6 units. Every single point of triangle ABC has been moved to the right 6 units to build the pink triangle. A translation is when a figure slides across the coordinate plane. Let's check out the example below and do one for ourselves. It says, redraw the figure following this translation, x minus 4 and y minus 2. I've already identified one point for us to look at the corner of the arrow. This is the point 2, 1. This transformation asks us to take every x value and subtract 4 from it. So 2 take away 4 is negative 2. It also asks us to take every y value and take away 2 from it. 2 taken from 1 is negative 1. So the point at the left corner of the arrow is going to translate to the point negative 2, negative 1. Let's take another point. How about the top? This is the point 1, 2, 3. 1, 2, 3, 4, 5. This coordinate point 3, 5 needs to follow the same translation. The x value, subtract 4, would be negative 1. The y value, subtract 2, would be 3. Negative 1, 3 now becomes the top of the arrow. Instead of writing out a long series of points, let's look at this visually. By moving each point, by subtracting 4 from each x value, we're moving the point left 4. By subtracting 2 from each y value, we're moving the point down 2. So every single point on this shape is going to translate left 4 and down 2 to its new home. So I'm going to grab a whole bunch of different points and start moving them. How about the side here? Left 4, 1, 2, 3, 4, down 2. That lands here. The opposite side, left 4, down 2 here. The bottom right corner, left 4, down 2 here. And now I can redraw the image. By translating every individual point, we've now translated the entire image. The x minus 4 moved the entire image left 4 units. Y minus 2 moved the entire image down 2 units. Okay. Let's take a look at reflections next. Using our example up top, we've got triangle ABC in the upper half of the coordinate plane. After being reflected, point A, point B, and point C have flipped over the axis of symmetry so that the figure lands in the lower half of the coordinate plane. A reflection is simply a flip of an object. Here, we're asked to do the same. We're asked to take this image again, this arrow, but redraw it as a reflection across the x-axis. Highlight the x-axis to give myself a visual here. That means every point on the upper quadrant needs to reflect to the lower quadrant, and it needs to move in an equal distance. So let's check this out. Let's start with the very tip of the arrow. This point is 1, 2, 3, 4, 5 units above the x-axis. When the image flips, it will now be 5 units below the x-axis. Let's try this left side. This point is 1, 2, 3, 4 units above the x-axis. So when it flips, it will be 4 units below the x-axis. The same will happen with this right side. 1, 2, 3, 4 units below the x-axis. Here, we've already built the tip of the arrow. Now let's work on the body. This lower left corner is only 1 unit above the x-axis, so when it flips, it will only be 1 unit below the x-axis. That will happen with this right base corner as well. Now I can draw the rest of the image. By reflecting each individual point, we've now reflected the entire image. Our final transformation to talk about is with rotations. Here, this image represents triangle ABC being rotated clockwise around this point O. A rotation is simply a turn. Well, let's use this as our first example. If you're standing on a turntable facing north, and after 20 seconds you've rotated 90 degrees counterclockwise, in what direction are you facing? Well, in our example up top, the triangle has spun clockwise, which is to spin to the right. So counterclockwise must be a spin to the left. So if I'm facing north and I spin 90 degrees counterclockwise, I will now be facing west. There are 3 more examples below that use translations, reflections, and rotations. If you need to listen to me walk through each of these examples, visit the next video.